Steel serves as the resilient backbone of our modern civilization, stretching from the deepest foundations of cities to the highest peaks of the world's grandest skyscrapers. From suspension bridges spanning vast oceans to skyscrapers that pierce the clouds, steel is the silent force that makes our ambitious architectural dreams a living reality. Yet, most of us rarely stop to consider that these incredible structures began their life as simple, humble red stones buried deep within the Earth's crust. In this journey, we will explore the remarkable transformation of raw iron ore into the sophisticated materials that define our technological era and our future. Witness the birth of a metal that shaped history, starting from the rugged mines where the story of every modern skyscraper and bridge truly begins today. This is the story of steel, an epic journey of fire and precision that turns the Earth's raw elements into the grand monuments of human ingenuity. At the world's largest open-pit mines, millions of tons of iron ore are unearthed daily, revealing the vibrant red landscape of our planet's hidden mineral wealth. Massive machinery, scaled to the size of small buildings, works tirelessly to extract the raw materials needed to feed the global demand for high-strength industrial steel. Each scoop of this iron-rich earth contains the essential building blocks of our world, typically holding 60 to 70% of pure iron within its structure. This raw ore represents the very first step in a complex global value chain that eventually produces the high-grade steel used in every modern infrastructure project. The scale of operation here is truly staggering, as these giants move mountains of earth every single hour to keep the heart of global industry beating. Before it can be transformed, the ore must be crushed and sorted, preparing the way for the intense heat that will soon unlock its hidden metallic potential. In this harsh, beautiful environment, human engineering meets geological history to start the process of refining the very earth into the materials of our future world. We now enter the heart of the steelworks, where a towering blast furnace stands as a monument to the power of heat and chemical transformation. Inside this furnace, temperatures soar above 1500 degrees Celsius, forcing the iron ore to release its oxygen and melt into a powerful, glowing liquid metal. This is where pure science meets raw mechanical force, a place where solid rock is surrendered to the flame and turned into a versatile, liquid power. The liquid iron is now ready for its next evolution as it moves toward the massive vessels that will convert it into high-quality, durable construction steel. In the oxygen furnace, a high-pressure blast of pure oxygen burns away impurities, refining the metal and adjusting its carbon content to achieve the perfect strength. The air is thick with the smell of hot metal and the roar of the furnace, creating a scene of primal power and sophisticated industrial control. Every drop of this molten steel is carefully managed, as its chemical composition determines whether it will become a car body, a bridge, or a skyscraper. Precision is key. Advanced sensors and robotic systems monitor the metal's properties in real time, ensuring that the final product meets the most rigorous global standards. Behind the scenes, engineers use sophisticated AI and data analytics to control the chemistry of the melt, perfecting the recipe for the world's strongest building material. Human expertise and machine precision work in harmony here, ensuring that every batch of steel has the exact properties required for its intended structural purpose. From the furnace's roar to the laboratory's silence, the journey of molten steel is a testament to our mastery over the elements and the laws of physics. The transition from liquid to solid begins in the continuous casting machine, where the molten steel is shaped into long, glowing strands of raw potential. As the steel moves through the molds, it slowly solidifies, forming high-quality billets and slabs that serve as the foundation for all finished steel products worldwide. Intense sprays of high-pressure water cool the outer shell of the steel, a critical step that optimizes the molecular structure for maximum strength and durability. The air is filled with hissing steam and the rhythmic sound of machinery as the steel undergoes this rapid, carefully controlled thermal transformation process. This cooling process is a delicate dance of physics, where temperature and speed are perfectly synchronized by AI to prevent any flaws in the metal's core. Massive cutting systems then divide the continuous strand into precise lengths, each section destined to become a specific component of our modern world. These red-hot slabs carry the heat of their birth as they move toward the next stage, ready to be rolled and shaped into their final forms. Nothing is left to chance. Laser sensors and high-speed cameras inspect every inch of the steel, ensuring perfect dimensions and a surface free of any defects. The rhythm of the rollers and the precision of the guides ensure that the steel remains perfectly aligned as it prepares for the final rolling process. This facility is a masterpiece of modern engineering, turning thousands of tons of liquid metal into solid, high-performance steel every single day without interruption. Now, under the immense pressure of the rolling mills, the steel is squeezed and shaped, undergoing a dramatic physical change that defines its final purpose. Thousands of tons of force press the glowing metal, thinning it out and lengthening it like a ribbon of fire, stretching for hundreds of meters. The speed of the process is breathtaking as the metal transforms from a thick slab into a versatile plate or a thin sheet in seconds. Mechanical power and fluid dynamics work together here, maintaining the extreme speed and pressure required to shape the steel into its high-precision final form. From thin sheets for car bodies to heavy plates for shipbuilding, the rolling mill dictates the strength and flexibility that each specific industry requires. The final products emerge: massive, gleaming coils of steel, ready to be shipped across the globe to build the machines and structures of tomorrow. Whether it's rebar for concrete or high-strength beams, this steel is now ready to take its place as the enduring skeleton of our global infrastructure. Steel is more than just a material. It is a legacy of human achievement, a testament to our ability to reshape the world through innovation. Today, steel also drives our transition to a greener future, forming the essential components of wind turbines and sustainable energy systems across the planet. As the world's most recycled material, steel embodies the circular economy, proving that our industrial strength can coexist with our commitment to environmental sustainability. The journey from red earth to grand structure is complete, building a world that is stronger, more connected, and infinitely more sustainable for generations to come.